Hello friends, in today's question, a man of mass 75 kg is pushing a heavy box on a flat floor. The coefficient of kinetic and static friction between the floor and the box is zero point 0.2 and coefficient of static friction between the man's shoes and the floor is 0 0.8. If the man pushes horizontal, what is the maximum mass of the box he can move? So this is the box and the man, it is going to try to push towards the right side, and the coefficient between the box and the floor is given as 0.2, and between the shoes of the man and the floor is given as 0.8. So we have to find out the maximum mass the box which he can move. So first of all, let's consider the box. So we can clearly see that box is only going to move when it is able to overcome the frictional force, or applied force is greater than frictional force. Okay, you can say box will move only when the applied force let us call it as F is greater than the frictional force. Let us call this as FRB in case of box. So we can draw the free body diagram for the box. So this is a box. A force F is being applied on it, and it is having a frictional force FRB. The downward direction, there will be MBG, where MB is the mass of the box, and in upward there will be normal, let us suppose that is NB. So we can find out what will be our FRB. You can say FRB will be equal to mu to NB, and NB is MBG. So we can say mu into MB multiplied by G. So now the applied force should be greater than the frictional force. So we can say the applied force should be greater than FRB, or FRB we already know is mu MBG. We substitute the value. You can say FRB mu is given as 0.2. Mass of the box we have to find out, that is MB, and multiply by G. Now let's consider the man. Now if the man is able to push the box, there should be no slipping between the shoes and the floor. You can say for man to move the box, there should be no slipping between the shoes and the floor. Okay. It means if FRM is the frictional force for the man, okay, you can say if FRM is the frictional force, therefore you can write the equation that FRM will be equal to the applied force F, and we can find out about FRM. FRM will be equal to mu multiplied by mass of the man multiplied by G, mu is given as 0.8, mass of the man is 75 kg, and multiplied by g. So we substitute both values, FRM as well as value of F. So let us this equation 1. Using equation 1, we get 0.8 multiplied by 75 multiplied by g is equal to 0.2 mb multiplied by g. So g cancels out. So from here we can say our mb is equal to 0.8 into 75 divided by 0.2, and this will be giving us mb is equal to 300 kg. So we can say this is the maximum mass of the box. This is the maximum mass of box which man can move. So this completes the question. Thank you.